we have understood the general structure of loops, we can go ahead and further our knowledge by understanding different types of loops. What are the different scenarios these loops can be used? So the first one we are going to look into is called definite loop. What is a definite loop? So suppose you have a scenario where you know how many times you need to iterate. In case of a roller coaster, we know that we have 1,000 users in the line and we have to process 1,000 users. So we already know that number and we know how many times we have to iterate over a certain task. So in that case, we use a control variable which is already defined. In our case, it was number of riders equals 1,000. Okay, so we know we have to process 1,000 riders, and the loop we use is while loop, which checks the condition, executes the body, and then ends the loop. Okay, if the condition is false. These kind of definite loops are usually implemented using some kind of a counter. In our case, the counter is here, number of riders. Okay, because we know we have 1,000, so we have initialized this to 1,000 riders, and then we go ahead and process the loop. We can also use some variable. We can call it counter equals 1,000. The reason I use number of riders is just to make it a little bit easier to understand the program. I could have just used a variable named counter. Now, there are two ways to implement this while loop. Okay, the first one is if we have to count forward. And the second one is backward counting. Okay, so what's the difference between the two? In our case, when we implemented the ticketing system using the loop structure, we use backward counting because we had 1,000 riders. So we initialized our counter to 1,000 and we counted backwards, right? So we decremented the number of riders every time we processed the loop. Now, we can implement the same thing using forward counting. How we can do that? In that case, we initialize our number of riders and we can call it number of riders processed equals 0 because we are starting off with 0 tickets printed, right? So the number of riders processed in the line is initialized to 0. So in this case, we can check that the number of riders processed is not equal to 1,000. Then we keep going, okay? And instead of decrementing the counter, after we execute the body, we can say number of riders processed equals, I'm just going to shorten it, number of riders processed plus 1. So in this case, we say number of riders processed equals number of riders processed plus 1. So we are incrementing the counter. So the next time it processes it, it knows that it has processed one rider, and now it's processing the second one. And when the number of riders processed equals 1,000, that means it has exhausted the line and it will end the loop. So that's an example of forward counting. So just make sure that whatever logic, forward or backward counting you use, so it's easier for other programmers to understand your logic. Now the same logic can be done using a different kind of loop called for loop. Let's see how for loop can be implemented to provide the same logic. We say for counter equals 0. So here we are initializing the counter. We check the condition. Counter is less than 10. And then we go ahead and update the counter. So a shorthand for updating the counter is, in some programming languages, you can do counter plus plus, which increments the counter by 1. Or you can say counter minus minus if you want to do backward counter. And then after you increment the counter, you execute the body of the for loop. Okay, so That's just a fancier way of implementing the same logic using something that is short and simple. So that's how the program gets executed in the for loop. Step number 1, counter is initialized. Step number 2, condition is checked. Step number 3 is when the body is executed, and once the body is executed, step 4 is when the counter is either incremented or decremented, and then after step 4 it comes to step 2, checks the condition of the counter, step 3, step 4, okay, and then it just keeps on repeating until the condition is true. So if you see here, we only initialize counter once, so step 1 will only be executed once, followed by the rest of the step 2, 3 and 4, which will continuously iterate until the condition is false. So we have seen the pseudocode for loop. In different programming languages, for loop is implemented with slight variations. So in Python, for counter in range 0 through 10, body of the program, just to understand how the loop works. So what it does is it generates this sequence, it puts the first value in the variable counter, and it executes the body of the for loop. Then it goes ahead and puts the second value in the counter. The counter value is 1, executes the loop, and so forth until it reaches the end of the sequence. So the counter value is 4. It will print this statement for the 4th time, and now there is no more value in the sequence. So it will end the for loop when the sequence values run out. Okay, but this counter just keeps track of which value it's going through in the sequence.